Well, with that, we can roll into our presentation on LCC tonight, if he's ready.
You bet. Happy to do so. You guys ready to dive into it?
Yes, we are. We're ready and eager to learn.
All right. Well, first of all, thank you, Mr. Borman and Larry, for allowing me to present here. This is a great opportunity. Appreciate you opening the door for us, as well as welcome to the LCC group. I know there's a lot of interest, so thanks for making this open to a number of people. Just to introduce myself a little bit here, Delif Gerpanik. I started model railroading when I was 8. I found a Cox, if anybody remembers that, rebranded HO set running around the tree that on Christmas time. And so I don't know. I don't think any of my parents thought that I would have ever took to it like I did. Anyway, what is it? 50 years later, still playing with trains, so, and love it. So anyway, started with DC, and then around 2004 went to DCC. Started with the MRC Prodigy Advanced system. Pretty neat. And I don't remember who mentioned it. I started with no sound, but once I started hearing sound, I couldn't get that out of my head either. So I just love the sound. Good stuff. Built out a switching layout, and then the next phase, built out an expansion on that. And GNW, as I call it, the Great Northwestern, went to a third layer of expansion. And as I'm building it out, I'm just finding that there's a need for a data highway or communications to happen for all the accessories. So we'll get into that. That was kind of an introduction. I also want to say, let's keep this interactive. You know, if you guys have questions, just interrupt me. The goal here is really to introduce the topic of layout command control. It's really not that scary. It sounds like, oh my gosh, you know, if DCC was bad, what about layout command control? It's got to be double bad or something like that. I hope I convey that at the end of the evening here, people feel a little bit more comfortable with it. Sound good?
Yep.
All right, so let me go ahead and present here and share screen. You guys should be seeing a beautiful sunset there.
Not yet. You're not sharing just yet.
Not? Oh, there it goes. I gotta hit the share button. How's that?
Perfect.
Okay. So the layout command control, what it is and what it can do for you. I'm really going to try to avoid getting into the technical weeds. One of the other things about my background is that I'm a mechanical engineer. My brothers consider me the knuckle dragging part of the family. My dad's a double E. My brothers are both double E's, and they wondered what happened with me. So I'm really not that much into electrical engineering. I noticed some of the names that are joining us here are LCC gurus and experts, and I fully expect to see an email at the end of this saying, hey, Gerpanik, you messed this up. I don't know, I'm just kidding. But if there's comments that people want to make or add to it, feel free. But we're going to just do an introduction. And like I say, the goal here is to hopefully take a little bit of the fear factor out of it. So we're going to talk about an introduction, what it is, how LCC works. It's a little bit different than your typical, the pieces to make it work, integrating it into your layout, and then there's these things called nodes. We're going to talk about how to configure those. Some simple examples of how to install one and use it. In fact, I got a demo layout here that we're going to get into. We'll do a little period of Q&A, and then actually I'll take my camera here. Normally I'd like to do this face-to-face. In reality, it's kind of a neat opportunity. We've got people all across the country here, so we'll just do it virtually. So what is LCC and what is DCC? And let's talk about that for a minute. DCC, digital command control. It puts a digital control signal onto the track itself, right? And it's not really AC. In the bottom here, you kind of see a picture of this, you know, red, blue, green, yellow diagram. And so it's like AC. It alternates back and forth, but the width of the pulses, I know positive and negative, if you want to call that an AC, actually communicates data, zeros and ones in the lower right hand, you kind of see that. And so it communicates as well as powers. So I think most of you guys know that, you have an intuitive understanding of that. And it's really designed to run trains, but it also runs stationary stuff. My previous incarnation of the GNW, I had stationary decoders. And many folks use that, and it's like, well, what's wrong with that? It works perfectly fine. And I agree, it works perfectly fine. You know, and we'll get into why you would want to add an LCC segment on there in a bit. Okay. So what is the difference between DCC and LCC? Why would there be some limitations on DCC? First of all, DCC is really a single direction communication from the command station, right? You get your throttle, you send the signal out to the locomotives, and it goes one way, and the trains respond to that. That's great. But it's one directional. The locomotives never talk back. And I know Digitrax was talking about transponding, but that really never took off, and it's really not designed for that. The other thing is the reliability comes from repeating commands. The wheels on the locomotive have, you know, momentary losses, and there's just a lot of noise, static, and things like that comes out there. And so there's a lot of traffic just to make sure that signal gets through to that decoder. So, and then you got another thing called network contention. So basically all this noise creates a lot of confused signals. And so the DCC system has to keep on resending that, okay? And the results, especially on larger layouts, if you guys have ever operated in a larger layout, there's a noticeable lag between the responsiveness. For the electro nerds out there, the data rate on DCC is about 8,000 bits per second, 8 kilobits per second. And rewind the clock a bit. Remember when 55 kilobits per second dial-up was the hot thing? You know, this is a fraction of that. That's the DCC data rate, okay? Now you add sound locomotives, and you got more locomotives. And I got a picture down here, and it's a lot like a train station when you got a lot of people around you, a lot of noise, and there's an announcement on the PA system. And you know, if anybody's been to a train station or even at an airport or whatever, and there's a lot of static and noise, what happens, right? Is that you don't always get the message. You've got a lot of interference. They have to repeat it a lot of times. And so that's one of the limitations. Does that make sense?
Yes. Mm-hmm.
All right, so here's the big idea. The whole thought on layout command control is fine. Just set up another network, set up another data highway just for running your accessories. So that's your track detection, your turnouts, your signals, anything else that you might have there. Got a picture here, you got one highway for your train control, and you got another highway for all your accessories. So that's the idea. All right, so how do we unload this DCC bus? And there's lots of options. LCC is just one of many. Probably the most popular is Loconet. And I've heard from the introductions here this morning or this afternoon that a lot of folks are running with Digitrax. I know some of you are using Loconet on Digitrax. It's very similar in some ways to LCC. It's a peer-to-peer network. You can have multiple nodes. They talk to each other. It's certainly popular. I do want to point out it is a proprietary licensed product, so you have to go through Loconet. There's only Loconet out there, and you know it's not an open architecture. And in terms of speed, it's roughly the same as DCC. So it's relatively slow. Now, admittedly, most of our layouts, you don't need a whole lot of bandwidth. So it's not that big of a deal. There's a couple other systems out there. ExpressNet by Lens, it's very popular in Europe. I haven't seen many people use it here in the US. I personally have not seen any. For those of you in industrial controls, it's based upon something called RS-485. It's an industrial control standard, pretty robust. And then Bruce Chubb put out his CMRI. I've seen on the internet, a lot of people use it. It's fairly popular. One of the notes on it, though, it does require a central computer. In other words, the nodes themselves are not intelligent. They process information, but all the brains runs on a PC. So there's some of the popular options that are out there, all right? So what about LCC? Why not just use one of those? Okay, so it's a separate standard. It was developed specifically for layout control. It's a peer-to-peer system. You do not need a computer to run it. You can set it up such that you have all these nodes around your layout and they just go off and run. Any device can talk to any other device. It's all bidirectional. Every device can listen to any other command from anything else. As I mentioned, it takes the load off the DCC bus. And it actually can talk to the DCC bus. It talks through JMRI. LCC goes through JMRI just like many other things. So you can actually talk to the DCC bus if your DCC is tied into JMRI. And I just saw, by the way, RR Circuits came out with a Digitrax, a Loconet to LCC buffer. So I understand that just came out, so you can have a direct link between LCC and Loconet now. A couple terms that you might see bubbling around here. LCC, this is a symbol that was put out by NMRA for LCC. Then you'll see sometimes this thing called OpenLCC, Open Layout Command Bus, I believe is what it stands for. And really, this is a bigger standard, if you will. It's sort of like LCC is a subset of OpenLCB. So when you hear LCC, sometimes you'll hear about OpenLCB. Don't get confused. LCC is the NMRA approved part of OpenLCB. Honestly, for the conversation, they are one and the same for us, but technically they're two separate entities. In fact, there was enough confusion on this, and I'll show it to you in Panel Pro here. Originally, they had the interface in Panel Pro as OpenLCB, but people couldn't find LCC, so they actually duplicated it and with the LCC label, and you can use either one and they function the same. All right, so what is LCC? Okay, as I mentioned, it's network. It's a network. It's based on the CAN bus, Control Area Network, not anything to do with Canada, but Control Area Network is actually something that came out of the automobile industry. Think about it. Automobiles run on 12 volts, right? They got a very noisy environment. You got a lot of static. You got a lot of radio interference. You've got spark plugs going on. Doesn't that sound an awful lot like a model railroad? It does. And so if you've heard of OBD2, like the interface that you have, that is actually CAN bus that you're plugging into on your automobile. And the idea is the same. It's a noise tolerant system that allows data to be communicated reliably. LCC bus operates at 125 kilobits per second and 1,000-foot maximum bus length. Again, this fits in really nicely. I don't know many layouts. I don't know anybody on the call here have more than 1,000-foot length on any layout run. Would be nice, wouldn't it? But that's going to cover pretty much anything that we need. And again, 125 kilobits versus 8,000, considerably more throughput. They've got, if you want to use some buzzwords, 100% data throughput with error-free collision resolution. I think that means something to the radio people or the communications people, but it does mean that it does talk very well. As I mentioned before, it allows microcontrollers and devices to communicate with each other without a host computer. So you can literally have nodes talk to each other. You don't need a PC. And of note is that LCC standard also supports Wi-Fi and Ethernet. So it's all set up such that you could actually, if you set up your layout, for instance, for layout command control, and you tie it into your Wi-Fi, you could literally operate a model railroad from a different computer in a different part of the country. It's already set up for it. And we'll get into the details of it, but I have an LCC node right here with a node ID, and it's a unique node. That node is the only node of that number in existence. So every node has a unique address. Now, what's neat about that is for the modular guys, if there's modular guys in the group here, you're always worried about when you plug things together that you don't have address problems. Well, LCC set up that every node right out of the factory comes with its own address, so you never have to worry about that. Once you set it up, you just plug them together and they can talk without any errors. Kind of cool stuff. All right, moving along here. How does it work? Okay, so the whole thing in layout command control is they have this thing called events. And that's kind of a buzzword. I know it's a new term or whatever, but an event is something that triggers an action, for instance. So I might have an event. Maybe there's something like a wheel is detected because it's hitting a detection block. That creates an event, and that's broadcast over the entire layout. And what you do is you set up the nodes to listen for that unique event, and then you could trigger whatever you want. You can have a signal turn red, or else you can have an indicator lamp on your control panel, show occupancy or whatever have you. You might turn on crossing gates or whatever. And because, remember we said those events are unique numbers, you can use that one time, multiple times, any number of times in any number of ways. So if you think about it, inside of this event, you've got some producers, that whatever, whether it's a button that's pushed or a wheel gets detected or whatever, and then the consumers, things that listen for that event. So here's a little picture. I got a push button, creates an event. Oh, I'm going to turn on a light. But you can have multiple events. You know, maybe it's multiple buttons. I have a place on my layout where I have a Y, and it's just awkward to get to either side of it. So I can run a push button off of either side, creating the same event and does the same action. Kind of neat. So producers, block detectors, push buttons, we talked a little bit about that. Consumers, something that responds, so a turn on a stall motor drive or a signal lamp. One or any producer can be used by one or many consumers. An example of that would be yard throat logic. You could create a producer, a push button on your panel, or could even be out of JMRI that says, I want to use route 3 into my yard. And then all the turnouts are looking for, oh, route 3 command, that means I have to be, and first one says normal, reverse, reverse, normal. It's naturally set up just to do that. Does that make sense? All right, keep talking here. All right, this is actually a picture of me when I was working with Arduinos. Many of you guys may have noted Arduinos are, well, why spend all the money on LCC? Arduinos do the same thing. They're basically the same voltage, and you can buy them for less than 10 bucks a piece. But you got to program the dumb things. You got this thing called a sketch. And I'm going to show you here later on how easy it is to program LCC. I think that's the big differentiator. If anybody's been thinking about Arduinos, it works. I got a whole interlocking station set up with an Arduino. And honestly, guys, it took me about a month to program it because you have to write the sketch and you have to debug the sketch. Again, I'm being transparent here. When I went into LCC, I did not want to make electronics my hobby. I just wanted something to push a button that throws a switch and it changes a signal light somewhere. And so LCC is more set up to configure the nodes. And the best analogy I can use is, you know, when you get a DCC equipped locomotive or when you put a decoder into a locomotive, you don't actually program, you know, you don't actually program the logic in there. You just go and hit your CVs. I want this bell, I want this horn, I want this speed curve, and then it runs with it. So you're configuring it. Does that make sense? You're really not writing code. In LCC, that's the same thing. You don't really write the code. It comes loaded with all the code to communicate and everything else. You just configure, oh, I want this button to turn on this light, or I want this instance to throw a turnout or whatever. So you just assign event a name. It can be numerical, text, combo, whatever you want. You keep track of it, and that name will be recognized universally throughout the LCC system. You don't have to worry about program. You got an additional node, you just plug it in. It instantly knows everything about all the other commands that are out there. Pretty cool, huh? All right, moving swiftly along here. Kind of an overview of the pieces. And I did want to mention RR circuits. There are a couple LCC vendors out there. And I think one of the complaints I've heard from people is like, well, it's an emerging technology and there's only one person producing it. Yes, no, maybe. There's a couple folks producing LCC components, but in reality, 90% of it, 95% of it is RR circuits. And it's kind of one of these chicken and egg things. Dick Bronson, who's the CEO, you know, he kind of stepped out there and said, I'm going to go ahead and put out a product suite and kind of get the ball rolling. So I don't know. I don't know if I want to fault him for that or anything else, but I think he's put some skin in the game. And I got to say, some pretty good products. And I'm not getting any kickbacks here. I'm just sharing that, you know, it's just been solid, at least on my layout. And I really enjoy the work, the products that he has. Anyway, so let's go through the different components.
Question
this is
for you, Detlef.
Yep.
Will LCC handle Boolean logic, or how do you handle a situation where you, for instance, want if A or B, but not A and B?
Yes, it has enough logic that you can go to town with an interlocking of like a New York Central station in New York City. It goes crazy with Boolean logic. I can show you, and I'm going to pull it up here in a moment to show you how to get in there. Absolutely, it does logic. Hang tight, Dave. I'll give you more in a bit here. All right, let's go through the components. I just want to show hardware first. First of all, there's this thing called an LCC power point. Basically, you have a power supply, a little wall wart kind of thing. And what it does, it actually energizes all the nodes around it. You don't need to send a power supply to all your different nodes. It injects, these are standard Cat5 cables. You can get them out at Micro Center. Go ahead and order them off eBay or whatever. Cat5 cables and 2 pair in there, 1 or 2 pair, I don't remember, is a power bus that powers whatever it's connected to. So that's kind of neat. You can power, I think on the LCC group, we've agreed roughly 6 to 7 nodes off of 1 power point. So it kind of cleans up your wiring for one thing. The other thing, you can see this little green thing here. It's called a terminator. LCC is wired up as a daisy chain, a single string daisy chain. There's no T's, there's no branches or whatever. It all has to be a single daisy chain. So on either end, you see one over here and you see one over here, there's a terminator. And it basically tells the LCC bus, this is the end of the bus, you know, we're done. So as you add things, you just remove the terminator and you add in a new Cat5 cable and you put your next node and you plug it in and it lets it know that's the end. All right, the next thing is your computer interface. This is it's called an LCC buffer USB. I'll show you what they look like. Well, this is what it looks like here. Basically, just like any of these other interfaces, if anybody's used a Sprog, it's about the same size as a Sprog. You just plug it in with a USB cable into your computer, and that's the interface that you'll use to program these or configure these nodes. The nodes themselves, there's actually 2 here. This one's a TowerLCC. There's 2 or 3 products, different kinds of nodes that are available from our circuits, and it's really the brains. There's a processor on board. It's the device that's looking at the traffic all the time. It's making the logic decisions, sending out the commands or repeating or whatever it needs to do. And then, okay, we talked about that, standard Ethernet cable. And then at the very end here are what I call the signal conditioning boards, but basically they're your I/O. You can actually wire inputs and outputs directly to the TowerLCC or the SignalLCC. But in some cases, you might want to condition the signal. And so let's just go through that. There's particularly two types of LCC nodes where the brains, if you will, live. So there's the TowerLCC. It has 16 input and I/O, inputs and outputs. So 8 and 8, 2 black connectors, and here's your Ethernet connector. That's it. So your inputs and outputs are here, and your Ethernet connections are here. So that's the TowerLCC. And each of the 16 I/O points can be configured either as an input or an output, guys. So let's say you have a whole bunch of switches you want to throw at a staging yard. Well, then you might want to just use one of these TowerLCCs as all outputs. Or maybe you have a control panel where you have a bunch of push buttons that you want to bring into the LCC. Then you just mount one of these in the back of your control panel. Now you got 16 inputs. Does that make sense? Now, as they were developing the TowerLCC, people realized, well, you know, when I get a signal, I need all kinds of outputs. And really, signals are pretty easy to do. So then these guys developed what's called the SignalLCC, and it has 8 input outputs, just like the tower, but then it has an additional 16 signal I/O. And these are just for driving LEDs. So if you have like a crossing or a control point or whatever, you pop one of these dudes in there and you can drive all your LEDs pretty easily and economically. Okay, and so these are the brains. We talked about the brains, the TowerLCC. These are the 2 types of brains they have. And then we have signal conditioning, okay? So on those input and outputs, remember how I was saying there's 8 inputs and outputs on the signal and 16 on the tower. What do we do with those? We can tie them into these, what are called I/O cards or signal conditioning cards. The BOD8 plugs right into there. You can see the connector right there. You plug it right in, and now I've got 8 detection points that are pre-configured, ready to go. You just plug it in. It recognizes it as a detection input card. Now I've got 8 detection points. So for your blocks. The SMD, similarly, is 8 outputs. You plug it in just like you would anything else. And now using the connectors up here, you can wire that out to stall motors, and you can drive 8 stall motors with it. And they also have an SESD for those who are still using coils. You can also run your coil switch machines as well. Straight plug in, you just have a terminal strip back here and you wire it out. So these are some ways to get the signals in and out of your LCC system. Any questions?
Can you give us some cost ideas?
Yeah, you bet. So your typical tower nodes or your LCC nodes, these are in the, I don't know, high 60s to low 70s, somewhere in between 65 and 70 bucks for these. And then the signal cards are in the $30 to $35 range. So I calculated it out, at least for my layout, all in, it was roughly $3 a point. So it's a good question because I would use LCC, and when you see the configuration, you'll know why. I would use it for all my train control. I would use it for all my signals, junctions, things like that. I would not, guys, I would not use this for just like accessory lighting. You know, if you want like spark effects coming from an arc welder or, you know, a signal tower with flashing lights and stuff like that. For those kinds of things, I personally would just go with an Arduino. You program it and you leave it alone. No communication, no smarts to it. It just does a fun special effect. And, you know, then you're talking about 20 cents or 30 cents a point, right? It's a lot more affordable. Does that answer the question?
Yeah, thank you.
Sure.
How about comparing it to a Digitrax SE8C, which will handle 8 stall motors and 32 three-color signal heads? To get that out of LCC, what would it cost compared to the $125 for an SE8C?
Okay, so this gives me, SignalLCC gives me 16, and how much are on the Digitrax card?
One SE8C is 125, I believe, going from memory, and that's 32 three-color signal heads and 8 stall motors.
Okay. Well, I would
jump in here because I just did this analysis in the last 12 months. The thing you got to do an apples to apples comparison, and you have to decide whether this is an additional cost or not, or a problem for you, is that the SEC 8 cannot operate standalone. It needs a computer. All of this stuff doesn't need a computer. Once it's configured, you don't need the computer at all. And so in my case, that was a huge benefit from the standpoint of I have grandkids operate my layout and all that type of stuff, and I don't want to have them futzing with the computer. But yet I want them to see the animation of the signals and that type of stuff.
Just one question here. On the SignalLCC, how do you tell it that you want what operation, whether a railroad crossing, a flashing reds, or a street sign with a street light with all 3 colors, or are you just going to turn a light on and off?
Stay tuned, Larry. Stay tuned. I've already got that question lined up for you in a few slides here.
Okay, that'd be fine.
All right.
Okay.
And Doug, you bring up another subject. That was one thing that that was a divider for me when I was deciding whether I wanted to do Digitrax, Loconet, or LCC, because sometimes I just want to come down to the basement and run a train around the loop. And I really didn't want to boot up the computer and all that. I just wanted to flip the power on and everything just goes. And I know that sounds silly not to want to turn on a computer, but I just didn't want to deal with it. And I just like the idea of I just come down there and it does what I want it to do. If I want to restage trains, I push the alignment for a certain yard track and it just does it. It doesn't, I don't need to worry about going to some computer. I don't need to worry about turning that on. It just is ready to go. So that was important to me. All right, cruising along here. Don't get too scared away by the picture here, but this is surprisingly simple if you really look at it, although you might not believe it. So you have your PC interface. If to configure the nodes, you have your power input. But this is really how you wire it out. So you got these SignalLCCs, and you can see the ribbon cable going up to your signals, very similar to some of your Digitrax products. You've got some current detectors that run back into your current boards here. You might have some fascia buttons that feed in. They're showing turnout power here. so that you can drive your stall motors. But I guess the key takeaway here is that it's pretty straightforward. I know it looks complicated, but it's pretty straightforward. You wire everything into these nodes, if you will. And once they're into the nodes, that's where the fun starts. You just start playing with how you want what to play with what. It's a lot more repetition than it is complexity. So this is how I started it up. And by the way, I got to give you credit, Dave Cochran, for thinking of this. I always had just mounted my electronics underneath the layout, and I was always wondering why I was getting a crooked neck here, you know, crick in my neck. So Dave turned me on the idea of you just put everything on a panel, a piece of plywood, and you can build it at your workbench, and then you slip it into a little track, and now you wire everything on the field side out to your terminal blocks, your barrier strips, and you're good to go. Just an idea. I thank you for that one there, Dave.
Your wiring is much neater than mine. Well, until you got to this picture.
Yeah, it didn't look so pretty after I got all the field wiring in. But really, that's how I put it all together. I just mounted the different nodes onto little standoffs on the board. I got these barrier strips going, and all my block wiring then came back to a common point. And here's where my DCC buses were coming in. Made it pretty easy. It's an example, guys. There's probably a lot better ways to do this, but it worked for me. Okay, there were questions asked about how do you configure a node? How hard is this? If you've ever used JMRI to either program a decoder, or if you've used JMRI for building a control panel, whatever, it's the same thing. You just open up Panel Pro. Inside of Panel, you create well, first of all, you connect it to OpenLCC, and now you can do it as LCC if you want. You create a new panel, you click on Configure Nodes, and I got it already ready to go, and I'll show you real time. And literally, as soon as you open it up, it goes out and queries all the nodes. This is actually right off my layout, a screenshot off the layout. You pick whichever node you're on, you click on Open Configuration dialog, boom. There's no programming here. Here's all your lines. Line 1, 2, 3, 4, 5, 6, 7, your 16 lines that we talked about coming in. You put your description right in here. I mean, literally, you type it in. What do you want to call it? What's the output function? What's the input function? And you just, whoops, sorry. And you just start going from top to the bottom on this configuration page, and you start filling in the data. And Larry, I'll show you some of the screens where you can do fading lights coming, you can do flashing lights, you can do, it's all pre-configured. You just pick what you want it to do. So here's an example. You start typing in a node name, Staging Detect Center and West End. When you start typing, it actually turns the screen or the field this orangey color. And what that tells you is the data hasn't been written out to the node. If I just click on this little right button, this coloration goes away and it just shows Staging Detect Center and West End. And what that does is it tells you that you wrote that now to the node. You can now disconnect your computer and it's all configured. You're done.
So at this point, you're saying is that LCC and Decoder Pro go hand in hand.
Yeah, and it's actually Panel Pro.
LCC without it, right?
Yeah, you actually use Panel Pro. Decoder Pro is set up more for the decoders. Panel Pro is more an interface for USB interfaces.
I found out that one of them can do some of the functions of the other one. I can't remember what. I've done Decoder Pro, so I understand it, but.
Yeah. Yeah, I'll show you. I'll actually bring it up here in a moment, and then we can walk through it. And then you kind of go through each. I'm sorry, go ahead.
So you can't configure this without a computer. So there goes you don't need a computer advantage.
Well, okay, you don't need a computer to have it operate.
How do you set a route?
You know, if you have a push button, you can set a route in Panel Pro. You can set a route on a push button on a panel somewhere out of the layout.
But Panel Pro is a computer again.
Yeah, I give you that, Dave. I'm not saying you don't want to necessarily use a computer, and I use a computer. You know that in our ops sessions. But I like the option of just coming down there without turning on the computer, and all the logic still works locally.
Yeah, I can see that advantage. I frequently don't turn on the computer when I go down to run a train, but then I don't get things operating automatically. But if you still need a computer to set this up, then financially, the computer still enters the equation.
That's true. That's absolutely true. Yep. It's very true, Dave.
Who doesn't have a computer these days?
Yeah, since I brought that up, the issue for me was I can configure this from my desktop computer, which is not in the layout room. And then the layout can run standalone. So that again was one of the things in my trade-off.
But there is one problem though. There are people who are totally happy with a tablet, an Android tablet.
Mm-hmm.
You can do everything you need computer-wise on an Android tablet except JMRI. As far as I know, there's no JMRI for Android. Am I correct?
I don't know that. I'm not a JMRI expert.
I think that you are correct. With one caveat, JMRI has an ability to run a web server, so you can in fact do things from tablets if you have it running on a computer someplace in your network.
Yeah, but you still have a computer.
Yes, you still have a computer.
Yeah. All right. Any other questions, discussion? All right. Scrolling down a little bit on these configuration nodes, as I mentioned, there's these 16 lines. And as you start going down, you just start giving each of the lines a description. Is it an output or an input? Are there delays associated with that? And you start going right down the list. Commands, is it, for consumer commands, if it's looking for something to trigger on, you find that number, boom, 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 and the state will be changed to, and there's a pull-down menu. Or is it a producer command? When that happens, you send out an event. And it sounds more complicated than it is, but once you start getting into it, you just start seeing the patterns. And literally by using copy and paste, they even have the copy and paste functions. You can have multiple windows open. Say, all right, I'm going to copy this into these nodes. Boom, boom, boom. Save. And now all those commands are written across those different nodes.
Detlef, this is Frank.
Yeah.
When it says function, what kind of functions are you talking about? Like it says output function. Where it says no function, what would be a list of functions?
You know what, guys? Let me just see. How far along am I? You know what I'm going to do is I'm just going to kind of fly through the rest of the slides, and I'm going to pull up Panel Pro and actually a real node.
Oh, okay.
And let's just do that. I'm just going to
Thanks.
see. Yeah, configure a node. All right, let me go through the screens on live.
Okay.
I'm almost done with the presentation part. We talked about the computer. Sorry, I brought that up. Multiple control points, we brought that up. Larry, this answers your question here. It's something called economy of communications. You can have local decoding of a command. In other words, you can send out a command that basically says slow approach. And then the node itself will say, okay, slow approach from the west means at the node level, these indications for this lamp, these indications for this signal, these indications for this signal. So by sending out one general command to that node, the signals all can respond appropriately for a particular situation, medium approach or stop or whatever it is.
I see, but these lamps are basically set up using JMRI though.
Yeah, I'll show you how they are set up. But the idea is the data highway only needs to really share what amounts to a track circuit. It says I've got an engine or something here, and that cascades to all your different nodes what the implications will be for whatever signal indications you have. So they gave the example, is the turnout straight or diverging? Is the main free or occupied? Is the siding free or occupied? And you go right down the list here. And based on all these inputs, the node actually does the deciphering and puts out the right signal indication. again, it's that whole idea of the distributed control. You don't really need to have all the signals talking to each other. You can have them, you can literally just start wiring out an LCC system at one control point and let it operate pretty much independently of anything else going on in the layout. Okay. So tying it all together, I like this picture because that's really what inspired me. I just love signals at a control point. Simple as that. All right, get out of this. I'm going to pull up. Well, before we go here, am I still sharing?
Yes.
Let me just show you what's going on here. And sorry for the aerial flight, but I've got a, hope you guys can see here. I've got a demo layout, okay? And basically what I have is a control point. You can kind of see it. I've got a rail car here. We've got a turnout. And then we got basically going out to 2 tracks. Does that make sense?
Yep.
And over here on this side, I've got basically power coming into a power strip. For track power, I've got an MRC PA. And I've got a 12-volt power supply for the turnouts. And then here I've got the LCC power supply. And you guys remember the RR circuits, this is what they call their power point. So this red hose is coming from my PC. Then the blue hose goes, I only got one node on this little demo layout. It's just this one node. Got a tortoise switch machine here. And then I mentioned to you, there's a signal conditioning board right here. So between, this is the node, this is the brains, and this is signal conditioning. So for the signal conditioning, I got a little push button, lets me throw the turnout, yay. It also drives the signals. I've got some demo signals going here, and I've got a demo signal back over here. So this is what's called a control point, BOD CP4 basically, but it's an I/O board for this SignalLCC. So the SignalLCC, these are all the wires that go out to the signals. Then I've got this one ribbon cable for all the other kind of inputs, which is the detection for the track. I've got the push button for the turnout, and then of course the output for the stall motor. All the way on the right side here, I have current detectors. I've got 4 blocks on this little demo, basically 2 for the tracks back here, 1 detection on the turnout itself, and then 1 detection back here on the incoming. So between all of that, it all fits into this one node. So just to get your head around it, now what I'm going to do is go ahead and get back to, sorry for swinging this all over the place, guys. Let me go ahead and share my screen again, and let's pull up. I'm going to go ahead and pull up Panel Pro. So in Panel Pro, I'm going to go ahead and first open up preferences so you guys can see what it is to set up. So anytime you add a new data highway or network, and I have a Sprague programmer, I have this OpenLCC. I could actually create one that's called LCC, but I'm not going to do that right now because the thing will get confused. But I could use either LCC like we talked about, or where is it? Here is it, OpenLCC. Either way, I'm going to cancel out of that. So I've got this gateway. It's
Can you enlarge that on your screen just a little bit?
I don't know if I can. No, it doesn't let me. Can't zoom. Unfortunately, I'm sorry. I wish I could figure out how to do that. I don't know how to. So I'm interfacing to the computer, CAN bus via LCC buffer. And it's literally a pull down menu, guys. I'm not like really smart on this stuff. Honestly, I literally just, it's just a pull down menu. That's all there is to it. And then your connection, I just left that as all default. And so now I'm all set up. So I save that. All right, fine, I'll restart Panel Pro. And let's see if we can get it restarted here. There it goes. Boom. So OpenLCC, you literally come down to configure nodes, and the window pops up, and here is my network. It literally is that simple. OpenLCC network. This is the gateway, and it's always the first item on your pull-down menu. That's the gateway into the computer. But if I click on this little plus here, this is the node, LCC test layout. And you click on this line, it says Open Configuration Dialog. Now it's actually reading from the layout, the configuration. So let me pull this up here. Everybody see that? And I know the writing might be a little bit small for folks, and I don't want to spend a whole lot of time showing this. But for instance, node name is LCC test layout SignalLCC BOD4CP. Okay, that's great. The node description, Rocky Mountain Train Show demo. Guess where I did this last? I'm going to make this Sunrise NMRA demo. You notice how it turned orange? It hasn't been written yet to the node. I click on write. Now it's uploaded that over to the node itself. And I can unplug the computer. Next time I load it up, it's all in there. So let's just go through the different lines. Line 1, I'm not really using. Line 2 is an occupancy detector for the right normal direction. Line 3 is an occupancy detector for the turnout. Line 4, and literally I just go through these and start assigning things. So to your question, somebody had asked, is it an output or input? You can only use one at a time. So I've got the input disabled because this is an output. This is the turnout control. So I want the output function to be a steady active low, and I'll get into that in a minute, and the input's disabled. Now if I wanted to switch it around, let me just do, for instance, an occupancy detector. The output is no function, but the input is active low. I just have to flop them around. What kind of choices do I have here? I can make it steady active high, steady active low, sampled. In other words, is it looking for just a momentary, alternate sampled? In other words, sometimes I want to push a button, and one time I push it, it's a normal direction, and then I push the button again and alternates to the reverse direction. By using this one, alternate sample, it actually toggles back and forth between normal and reversed. Pulsed active high, in other words, maybe I just want the thing to go on for a moment and then turn off again. Sample pulse, alternate sample pulse, blinking. You see what I mean? There's so many choices here. It's crazy. And then same for input functions. You can have active high or low. That means it's either on or off, alternate action, sampling, alternate samples, or disabled. So you start going through it and you just configure it, right? You can go through all these I/O points and configure it however you want. So then once you get your I/O defined, then you keep scrolling down. Is this going to be a command, a consumer, or is this going to be a producer? In other words, as a consumer, when this happens, now I'm going to trigger these other events. See, in this particular case, I want to make sure the turnout moves the right direction. Then I want to send out all these indications. So it actually just lets you go right through and decide, you can decide what you want to do with those producers or consumers. Dave, you'd asked about logic. Keep scrolling down here. Logic events processing. It says 32 logic fields. I'll just stop here on logic 1. So for logic description, to our stop control point occupied. So this is from the right side. I have, let's say the unit's occupied. And you just simply start going through there. You know, what's it triggered on? What's the source of the trigger? What's the command? What do the events get set to? And so on and so forth. So you can do, you know, you can really build up a logic. And this is just one of 32 logics inside of just one of these nodes. I'm not aware of anybody needing to do a whole lot more than, you know, even 4 or 5 lines here. I've used, what, 10 for and I really just made it simple. I didn't want to even compact it too much.
Thanks for showing that, Detlef.
Yeah, you bet. Hey, it gets better. You keep scrolling down here. Select your mast. And this is the segment rules to aspect. You can set up a rule and it creates all these aspects. So you select a mast, and then you, within each mast, you can have whether it's a normal or unused or linked to previous. So if you have a really complicated mast with multiple heads, you can link them. Your ID is eastbound signal, for instance. Here's where you set up your lamp fade. You could set up a lamp fade. Is it incandescent or not? And then you start getting into the rules. Rule 1 is stop. Rule 2 is clear. Rule 3 would be take siding. Rule 4, stop. I set all the defaults to stop if I'm not using them, but you could have up to 8 rules for just one mast. And then here's the event to trigger that aspect. And if you have that aspect triggered, now you can send it off to another one as well. And if that's not all, wait, there's more. Here's your individual lamp controls, lamp 1, 2, 3, 4. For each mast, you can have up to 4 lamps. And of course, you can gang them together. And you want it, for lamp 1, you assign them to a particular I/O point. What kind of lamp do you want? Do you want it steady, a slow or medium flash, fast flash, none? Or a B cycle? You could do A or B cycling. In other words, you could, for like a railroad crossing, you'd have an A and B, right? You have slow, medium, and fast speeds on them. Some other effects, transition down, H2 red flash. I don't even know what that is. You can put a strobe onto it. You could make it, for like an alert or something like that. I don't know. I didn't use that. More effects. That's there. Track circuits. This is where I mentioned before. I haven't really used these, but track circuits allow you to communicate to the next mast. And by the way, guys, you don't have to use all these functions. I only use the top 2 or 3 blocks here. I never really get this far into it. And then at the very bottom here, this is the coolest part. I noticed that the green on my signals was super bright. I don't know why, but they're super efficient LEDs, and the red was really dim. So you can set your brightness, 128, 128. The red was, I turned it down to 20. You can set your brightness on all the lamps on your signal head just simply by configuring them from your LCC node. Anyway, it's kind of a guided tour of just one node, and then you can do it the same for all the other lines that you go through. I wanted to show you one other thing, again, trying to convey how easy this is. So I've got the buffer, LCC buffer here, and then I've got one node, right? So I actually have another LCC node right here. Fresh out of the package, never been used before. So I'm going to take it out of its package. I'm going to turn off the power to the LCC node, turn this thing off. And I'm just going to basically unplug one of the Ethernet cables, add a new cable. I don't know if it's crazy or not, but I'm going to close out of this so we don't confuse it. And I'm going to go turn on the LCC network. I'm going to go turn on Panel Pro. It should pop up here in a moment. Okay, OpenLCC, configure nodes. Oh, look at that. Here's our new node.
Wow.
Open configuration dialog. This is reading from that brand new node I literally just pulled out of the package. And here it's reading it, and boom, line 1, 2, 3, 4, 5, 6, 7, 8. There they all are. And I can start programming.
No smoking wires.
Nothing. You don't have to sit there figuring out the communications protocol. You don't have to give addresses. It's already uniquely identified. I start typing in the name.
This is Dave. I have one question.
Yes, sir.
You showed us how to program.
Mm-hmm.
You showed us the configuration.
Yep.
How about troubleshooting? When something doesn't work.
Okay. Define trouble. Is it trouble on
well, you wrote a program, and with the belief that the lights would come on and there'd be a certain brightness and all that.
Yeah.
So how do you troubleshoot something that doesn't work?
Well, my way of doing that is I just do one thing at a time. If I configure a push button, Dave,
Yes.
you know, I configure it and then I go to the layout and I push it. Does it
Okay.
do what I want it to do? And I configure a lamp. I see if it turns on or not. That's how I
Oh,
do
there's
it.
one thing on this. Can you reset things back like on a decoder? You have CV8. You get yourself so fouled up, you just go back and start over again.
See this
It
little
doesn't
button?
look like you can do that to this.
Sure you can. See this little button down here? It says backup. So I can create a backup right here, config.txt, right?
Oh,
So I just saved that right now. So what I did is I just saved that configuration, and that's really a good point, Larry, because
Okay.
you know, if I mess this thing up, I want to be able to. So I just click on restore. Now I can go back to that exact same config file right here, and I open that up, and now it'll restore that all the way back to what I had before.
Oh, so when you install a node, ideally is you do a backup as it comes out of the box. So you
Exactly.
have your starting point.
Exactly.
Yeah.
Other thing is, you know, as you can imagine, at first you just sort of make it turn on a light on the panel, and it can be pretty simple. But you start playing down here with some of this logic, and you know, it does get involved, especially if you have a complicated junction. Well, what if I smoke the poor little board because I dropped a screwdriver on it or something? I always like to make a backup of all my nodes when I got it the way I like it, just in case something goes wrong. Then I can just hit restore when I get a new node. I've never had one fail, but just in case, you know, belts and suspenders.
But it's also the case that out of the box, these boards don't do anything. I mean, you have to tell it what to do. I mean, configure it in some way. The default configuration does nothing.
Yeah.
Right, but you might want to go back to that point.
Yeah.
To do nothing?
If things are already messed up, it doesn't look like you can mess things up as bad as you can mess up a decoder. Because I've got the wrong CVs checked for a decoder, and the engine's all bonkers, and I have no idea where it is. You have to go back to 8.
The mess up, if I can use the term mess up, is I learned early on I need better documentation, because I thought I'd just do this for a couple switches just to see how it works, and I kind of had it in my head what I wanted to do. Well, now I have probably 24 nodes on the layout, and I go back to some of the old work I did, and it's like, what did I do here? So what I have to do is, it's more of all your IO points. I have a separate Excel spreadsheet that I put together just to keep track of, all right, this switch goes to this node. You know what I mean? It's some of that. And the other thought I want to share with you guys, if you get into this, kind of set in your mind, because this is so flexible, literally you can have any event trigger any other event. You have to start deciding, okay, is the switch event node name going to be the driver, or is it going to be the push button node name that's going to be the driver? Because you can use either, right? Anything talks to anything else. So it's really up to you to start standardizing, okay, for all my switches, I'll always use the switch name to drive that, anything associated with that turnout. You know what I mean?
Yeah.
It's more of a naming convention and just standardizing on how you do things. Because if, you know, sometimes if you use the command from the push button, and sometimes you use the command from the switch to be thrown, you know, then you're like, well, which one is it on this? You know, you kind of have to think about how you want to.
So, and just to clarify, the events names, there's no semantics to the name. It's just a tag that you're using in your system, and it only means something in your system, right?
Right. Here, so for instance, I'm going to go ahead and mess up this. So like this line 1 description, I'm going to call it test 1. So I can write this now. Notice what happened on line 1. It gave this tag test 1 to it. So it already identified it, right? And so let's say it's an output function. I want to say it's active, steady, low. That's typically how you drive a stall motor. So in this one, then I want to turn it off because I can't do inputs and outputs at the same time. So you write this and you write this. Now I've configured this as an output, and a lot of times that's all you need, because now this line is actually working as a stall motor driver. I'm done. I don't have to go through anything else. Oh wait, I do actually. I have to say it's a consumer event. When this event occurs right here, this event down here will put, oh, and then I got to tell it what it does. It does, yeah, line active. So I write that, boom. Or line inactive. That depends if you want normal.
Where did the ID come from?
And this ID is set up as a unique ID to this node that I just installed. It's a unique number that ends with F1, and then under the F1, I'm getting into the weeds here. These are the numbers after the F1 are the unique commands that this thing will respond to. But I could literally copy and paste any event number in here, like where it came from or where it's going to, from another node. You know, I was saying before, you could always open up another node. Configured echelon. Let me get the other opened. Stand by, guys. It's reading, it's reading, it's reading. There it is. So for my test layout, occupancy detector on the left lead. Okay. So on the left lead, there's no output. It's an active low on the input. So it's a consumer event on the producer. When that thing produces an active low, it's an active on. See this little number down here? That tells me that block is occupied. So I could literally copy, and it's going to consume that same event here now. I'm going to paste it in here. Now look what happened. Do you see what just happened?
Yeah.
This command here is used in all these different things. And now I just happen to have set up that this is going to output to a stall motor driver. And maybe this is like a reverse loop that when this block gets occupied, automatically this turnout will get thrown. So it's automatically lined up the right way. And oh, by the way, it's used for all these other things as well. See how powerful that is? See how dangerous that is?
Yeah.
That left to be clear, what you're saying here is once you put in that event ID, then it automatically says, here's all these other things that are currently using this. So you do have some documentation. It's a little bit, okay.
It's self-documenting, exactly.
Nice.
Yeah, very nice.
And along those same lines, I see you have a node description on top. How long are these fields?
I don't know, I've never tried. Let's see. Pretty long. It truncated a little bit.
It's like about 20 characters.
Yeah.
And node name and node description, they have a similar, I'm just wondering how much information you can put up in node description, for example, from a documentation standpoint.
Oh, let me just, I think description is longer. Somewhere I read it in the literature that description has more characters available. So that one concatenated, they both concatenated.
All right, cool. Thank you.
Yeah.
Is there, and I noticed that the events are all numbers. Is there some human understandable string that you can associate with those numbers?
Well, when you use the event, it tells you what you had used the previous description. So it's kind of a yes, no answer. You have to copy, they make it easy, copy paste. The actual information is this messy number, but as soon as you paste it, it tells you the description that you used. So yeah, I don't use the text or the narrative, you use it, but you just use the copy paste function and it carries the information with it. So yes, no, sort of. How's that for an answer?
Yeah, I got it. And the event ID is basically comes from the hardware.
Right. That's right. But keep in mind, I can change the event ID to whatever I want. I can even change the hardware node ID, whatever I want. This is where I'm saying you kind of have to think first how you want to structure, how you want to number and name things. Because it's so easy just to say, oh, I'll just copy and paste it over here. And then you start doing this on a number of different nodes. And it's like, wait a minute, who's producing this event really? You know, and you have to start thinking about how you want to, you know, what drives what.
Just to interject, Detlef, isn't the line description up here tell you what that event ID is going to do?
Yeah.
So that is your layout's description of what this event is. And the event ID is just used on the network to tell any other node what that is. But really the line description is the human description.
Yeah, that's right, Larry. But the question was, can I just use the description? And you have to use the node number.
Absolutely. Yeah, the ID tells every other node what to do, but the human thing up above where you had the line description is your definition of what it does.
That's exactly right. That's exactly right. That's exactly right.
So this
For
looks
the
actually pretty flexible, and you can do signals or detection or whatever on a single board. And
Yeah.
if you could just describe what you have to go through to get detection into one of these.
Okay, I just want to show you something here. So I'm going to write these real quick. I'm going to go ahead and refresh the node here. Refresh. See, it all carried it over. Pretty neat, huh? So you do have that numeric connection, but all the nodes understand the description piece of it as well. Okay, to your question, Dave, for detection, this is the detection on the left lead of this demo layout, right? So I'll just walk through it one line at a time. The description, occupancy detection, left lead, I know, very creative name. Output function, no function because it's a producer, right? It's receiving some sort of an input and it produces a signal. So there's no output, it's receiving it. So the input function, the way these detection blocks work is that it's normally high, but when the block's occupied, it drives the signal to low. So it's an active low. Does that make sense?
Yeah.
Normally high, active is low.
Yeah,
Now, if I wired my stuff up backwards, I can just simply move this to active high, and now my signals will operate reverse, right? But I'm going to leave it at active.
That makes sense, but I guess I didn't ask my question correctly. I wasn't looking for a software answer. I was looking for the hardware necessary to make that occupancy connection.
Oh my gosh, that's easier, way easier than this. Let me carry my little camera. Let me turn off screen share so you guys can all see this wonderful layout. All right. Okay, so nobody laughed that I was using number 22 wires to feed power to the track, okay? No comments, please. So here's my power in. I basically, this is the DCC input going to the tracks. And so for each of the track wires, I have one of these. Can you see that on screen?
Yep.
I have one of these detection coils. I don't know if you guys have ever used these, but it's not like an optical detector. It's actually a coil. And so when there's any current on the track at all, I mean, literally 1 milliamp. Take a look at this. Here's a detection board. You see how that lit up? I mean, I literally, I'm just putting my thumb on it. I'm putting my thumb on it and it detects, you can see the light slide up there.
Yeah.
Isn't that amazing? So it's literally just one milliamp will trigger it. It's 1 milliamp. Anyways, it goes through these coils and you just simply wire up to these little, here you go. This is that signal board. You just bring the 22 wires right in. That's it.
Okay, and the source of the coils, and do you have to just pass the wire through once, or do you have to go?
No, just once.
Around a couple times.
No, just once. I don't know if you can see that. Do you see how it just goes? The track power would be the orange wire. And then the two leads are your signal to the board.
I just want to say that some manufacturers, different manufacturers say go through twice. So it depends on the manufacturer.
You don't, I mean, this detects down to 1 milliamp with this setup. 1 milliamp, that's pretty slow. That's pretty low.
Yeah, that's pretty cool. Thanks.
Yeah. Yeah, and all the signal conditioning set up. In fact, they got even pots right here. You see these little pots? And if you want to adjust the sensitivity, you can tweak those up or down depending on what you want to do. So that's it. It's literally just 2 wires.
Neat. A lot more flexibility there than the SEHC.
Yeah. I got to say, I'm pretty pleased with this.
Why are block signals flashing on and off?
Oh, that's just because it looks steady to the eye here, but the refresh rate on the video camera.
All right. Okay.
Yeah, but you know, if I roll my little, there we go. See, it's now detecting turn 2 reds.
Nifty.
Isn't it nifty?
Nifty.
All right, I got to show you one more thing. So nifty. I had to do it, but you can kind of see the yellow flashing there.
Yeah.
Yep.
That's yellow flashing with an incandescent effect, all pre-programmed in. How cool is that?
Very nifty.
All right, any other questions?
Yeah, I have a question. So if I invest in the hardware, and where do I go for help as far as?
Well, I'm more than happy to help you, Richard. But I would also recommend that you sign up for the LCC. It's a groups IO group, and there's some amazing people on that group. You know, I think Doug, you've gained from them as well.
Absolutely.
And, Larry, I know you've posted on there and got a lot of good advice. I know I did when I first started. It was just like a jump into the deep end of the swimming pool, and I was pretty terrified about the whole process. But once you start doing it a few times, you start going like, oh, I get it. But there are some good guys out there. So I would suggest that, you know.
If I can give a plug, go to Detlef's site where he has all kinds of tutorials and video walkthroughs of the JMRI, how to program nodes. And that's how I learned. He's got some incredible little videos that are fairly short and specific on a topic and show you exactly how to program a node and how to hook things up.
Thank you. Detlef, can you put your website address into the
Sure.
chat?
Sure, you bet. Will do.
Yeah, look, one thing you mentioned that I found useful at the very beginning of the presentation was this sense that CAN bus works in a high noise environment. Because one of the things I was worried about is over here is I have all my bus lines all running close together, for example. And I was curious, if I run the LCC node through, or rather the LCC network cable through here, is that going to cause problems? And you answered that right off the bat. And that alone is worth me sitting down here at 11 o'clock my time to listen to.
Well, thanks for joining us. Yeah, honestly, I'm actually shocked and surprised on how robust this thing is. I've had 0 issues with it since I installed it, you know, and I'm a newbie. I just put it in and it just works, so.
Yeah, Detlef, you cleared up one thing. My layout is not going to be large enough to really need to isolate another path for DCC, but I see it does a lot more than just simply remove traffic. It can do things DCC can't do. So
yeah,
this has been a big help because I had no need for it till now.
Right. Right. And I honestly, Larry, I thought I would just use this. The only reason I got into this is because I wanted that routing feature for my staging yard. And I thought that's all I'd use it for. So I bought like 4 or 5 nodes and I thought that'll be it. I've spent enough money on this. It's kind of addictive, I'll be honest. It's sort of like it's a gateway drug, man. You start using it and you go, oh, wait a minute, I could do this with it. Oh, wait a minute, I could do this with it. And it just starts working and you start putting it in there. And like I say, I probably have 24 nodes now.
I'll second that. It is addictive.
One last question for me. You mentioned the stall motors and coil motors and whatnot. I'm putting servos in back here. So is there a servo driver board made yet?
There is a lot of talk about it. Dick Bronson from our friends over at RR Circuits recognizes that servos are kind of the next thing for turnout control. And he's posted that he's working on a project that'll address that, I think is the way he put it. So I don't know what the timing on that means, but I think there's something coming on that.
Okay, cool, thank you.
Mm-hmm.
Anybody have any other questions or anything, or?
Yeah, one more quick question, Detlef. Could you interface a CDS cell between the rails such that it would trigger. You know, it's basically a light activated resistor.
Yeah, so the actual node board is a 0 to 5 volt signal. That's all TTL logic, the nodes themselves. The interface boards, then you can interface to other voltage levels like the stall motor drivers and so on. So I would think whatever you, if you had some sort of a device that could take your CDS and convert it to a 0 to 5 or some sort of TTL logic interface, then you just use that. Does that make sense?
Yeah, kind of. And, you know, I've got all my detection and stuff already done by Digitrax boards, but I can see using some sensors, light activated sensors, to operate a grade crossing using LCC, especially since you can set it up and then forget it. You turn the layout on, it's not going to interfere with my interface to Digitrax or to NCE. It'll be standalone and could operate grade crossings.
Sure, sure. Yeah.
You know, Dave, you just reminded me of something that was one of my trade-offs. I'm a long-term Digitrax user, and so I have investment there as well, including using BDL-168s as my detection. And one of the things that I was able to work out with Dick Bronson, who's the CEO of Railroad Circuits, is that you can play with both of them at the same time. So in my layout right now, my whole entire staging area is detected with Digitrax stuff. And then as it transitions to the main line, I'm now using LCC detection. Now I happen to be using JMRI as a bridge between those two, but my Digitrax talks to LCC. It drives a signal both on panel as well as trackside. And you heard there is now a new product coming out that has been announced, although I haven't seen it on his website yet, that would replace my computer as that bridge. And so Loconet and LCC CAN bus can live on the same layout without a computer, and they would be talking to each other. So that is, there's not a mutual exclusivity there. It's sort of what you want to do and how you want to flavor it. And the flexibility is amazing in LCC, which is, Dietlef has already said that, so.
Yeah, I've already got Digitrax and NCE running into the computer, and I really don't want to try to add a third and, you know, clutter up the whole interface. The advantage I see here is it could stand alone without connection to the computer for grade crossings and maybe triggering music from a bar when a train goes by or something like that.
Yes.
Anything else? All right, if not, thank you, everyone. Appreciate it.
That was a great presentation. Thanks, Detlef.
Fantastic.
Yes, thank you for taking the time and doing the presentation. And thank you for everybody here that came from the LCC group and from around the US here to participate and listen in this tonight.
Thanks for letting us join.
Not a problem. We're glad to have you.
All right. Good night from Ohio, guys.
Night.
Good night.
Thanks,
Night.
Right?
Good night, everybody.
Good night.
Interesting.
Recording
lot.
and everything work for you there, Larry? You're muted, Larry. We can't hear you.
Okay. This time I'll stop the recording first to make sure it stopped before I exit.